on Monday when we learned about the sine function, we used the psi values at each radian degree. This time we're going to use the cosines, the x values. Okay, so the cosine of 0 is 1. So we go back to our graph. In a graph, when x is 0, y is 1. Okay. Then we go back to our unit circle at pi over 6, and we find the cosine of pi over 6. So at pi over 6, the cosine is really 3 over 2. And when we plug that into our calculator, we got 0.866. Any questions? So we're going to graph at pi over 6, cosine is 0.866. This counts 5.5, 4.5, 0.6, 0.7, 0.8, and kind of close to 0.9. Any questions? So we'll go back, pi over 3. At pi over 3, our cosine is 1/2. So we'll graph 0.5 right here. At pi over 2, our cosine is 0. So we're going to graph 0. Terrell, at 2 pi over 3, what is our cosine?
2 pi over 3 would be half.
And it is negative, right? At 2 pi over 3 is negative 1/2. So it's going to be down at negative 1/2. Okay. Then we're going to 5 pi over 6. Julie, at 5 pi over 6, what is my cosine? Very good. 33 over 2 is negative 0.866. Very good. Okay. Yep.
The positive side of 3 was 3.4.
Oh, no, 3.5, thank you. Fine. Definitely fine. Then at pi, Isaiah, what's pi? Cosine of pi? Negative 1. So you get 7 pi over 6 is 7 pi over 6. And my cosine of the x value, which is negative 0.866. So that's here. And at 4 pi over 3. Nate, what is it? 4 pi over 3. In the unit circle.
Negative 1/2.
Negative 1/2. Right here. Okay, everyone's doing the last few. Using your unit circle. Hope these figures are got the hang of it. equation. Okay, we have the same equation, only difference is instead of sign here, it's going to say cosine. But all the same parts. So my A value, what's the A value class? Yeah, let's do it. Okay, how high and how low it goes from the midline. Okay, how high and how low the periodic function goes from the midline. Okay, so we have to review what the midline is. The midline is equal distance from the maximum and minimum point on a periodic function. The line that is equal distance. Max on the periodic function. Any questions on it? Okay, so let's go back to our graph that we just graphed. Okay, that was our cosine curve. The midline is right here in the middle. Remember for today we said that the midline is always going to be y equals 0, just like with sine, y equals 0. So the amplitude is our equal distance. From here, it goes up to -1, and here it goes down to -1. Johnny, so what's my amplitude? So this right here. 1, right? Goes up to 1, it goes down to -1. The amplitude is 1. Any question over that? Okay, now when you do those B, can someone raise their hand and tell me what my B was doing? Frequency, very good. Frequency is just how many cycles there are between 0 and 2 pi. So if you write that down, this is frequency. And it is the number of cycles between 0 and 2 pi. Any questions on that? So that's how fast it curves. So is it going to curve really fast and have a lot of waves between 0 and 2 pi? Or is it going to be really wide and have just 1 or maybe a half of 1 between 0 and 2 pi? It's also what we do with our period, right? When we graph them, we talk about the period. And the period is the length of time. Takes the periodic function. Complete. One cycle. Okay, does anyone remember the formula for our period? Same as cosine. Go for Hannah. Very good. Minus 3 pi over questions over that? Okay. So let's go back to our graph. Okay, so here is our coastline. Our period then is from here all the way to when it starts repeating again. The period here is 2 pi. Any questions over that? Okay, so just like we did yesterday or on Tuesday, we want to find the cosine function, find the amplitude, the frequency, the period, and the midline. Remember for today, the midline is just going to be y equals 0. It's not until we start adding things outside of here. Once you add something here, then your midline will move up. Okay. Once we shift it. But today, we're not going to be adding anything to our functions, so the midline is just going to be 0. Any questions on this? Carly, what's my amplitude then in this equation? 3, very good. Bianca, what is my frequency then? Okay, it's the number for the cosine. It's 1. Since there's nothing written in, it's 1. Okay, then we have the period, which is 2 pi divided by b, which is 2 pi divided by 1 then. The period equals 2 pi. Any questions over that? Okay. Okay, do the next one on your own. Most of us got this correct. The amplitude was 2. The frequency was 1/2. And then the period was 2 pi divided by 1/2, which equals 2 pi times 2/1, okay, which is 4 pi. Any questions over that? Okay, the next one. The midline is the same. Yep. Well, because when you divide, you have to multiply by the reciprocal. The reciprocal of 1/2 is 2/1. Because there's a negative here, we need to remember that that's a reflection, just like in all of our graphing. When you have a negative A value, it's a reflection. Okay, so our normal cosine curve looks like this. When you reflect it, it's going to look like this. It's going to be upside down. It's going to start down and then go back up. Then we need our amplitude is just 1. You don't use the negative. Don't tell me it's -1 because the amplitude is constant. The frequency allows us to confuse by. There's a 1 in front of that theta. The frequency is 1/3. The period then is 2 pi divided by 1/3, which is just 6 pi. Any questions over that? Ready? Okay. Now let's graph it. Hey, graphing. 6 pi. Yep.
I haven't seen a difference between this lesson and the last lesson. Like,
Okay.
is there a difference here?
Yes. The very first graph.
Okay, yeah, I saw that, but like, what? I don't understand. That's not really that big of a difference, is it?
Okay. All the steps are the same to graph them. They're just going to look slightly different.
The graphs are?
Yes.
Oh, so they're gonna go up and down?
Well, sine went up and down. Okay, we already talked about the big difference here. Sine normally starts at 0, right? Sine curve starts at 0 and makes the curve. Okay, cosine starts at the amplitude and goes down and makes the curve. Okay, when you put them next to each other, they're hard to distinguish between which one's which.
Is cosine gonna be opposite? Because that's the COS. Is that gonna be sine?
When we graph sine, it was sin, right?
Is that cosine?
That's cosine. This is cosine.
So,
On our unit circle, the sine was the y values when we looked at our unit circle. Today, it's looking at the x values, so that's the cosine values on the unit circle. Any questions over that? Okay. There's just small little differences between today and on Tuesday. Okay, so our same thing we start with is our amplitude. Class, what's the amplitude here? 1. So here we're going to go to 1 and -1. Okay, we need to find the period, which is 2 pi divided by the frequency, which is pi over 2. So I'm going to get 2 pi times here again, I have 4 spaces in between the 0 and 4. Okay? So this is our start point, it's a period. It's our end point. It's a period. You want to find the start. What I'm counting by. And that is the period divided by, because I want 4 key points, I divide it by 4. So it's 4 divided by 4, so I'm counting by 1. Any questions around that? So then I do 1. 1 plus 1 is 2, plus another 1 is 3, plus another 1 will give me 4. Any questions on how I got that? Okay, now we can plug in our numbers. So we do the cosine of pi over 2 times, we're going to plug in 0 first. Okay, pi over 2 times 0 is 0. The cosine of 0, I'm going to go back to our unit circle. And the cosine of 0 is 1. So when x is 0, my cosine is 1. But I'll plug in the next one. I'm going to plug in 1. So I'm going to get the cosine of pi over 2 times 1, which just gives me the cosine of pi over 2. Okay, Victoria, what's the cosine of pi over 2? Look at the unit circle. Look at pi over 2, 0. It gives me 0. Then I'm going to plug in 2. I'm going to get the cosine of pi over 2 times the 2. Pi over 2 times 2 is just pi, so I get the cosine of pi. Alexis, what is your cosine of pi? Look at your circle. Negative 1. So it's going to go down here to negative 1. After that, where should it go, class? Back to 0. And then what? Back to 1. And if I want to continue it, I can go back down. Yep.
I can't find 2 pi on the thing, on the circle.
It is on the unit circle. It's at the very end, it's where 0 is. Oh, it doesn't say 2 pi. 55.25. It's 216.5. Any questions? We're good? Okay, next one. Okay, so this one reflects. This is a negative. So it reflects across the x-axis. So again, it's going to start down and then move up like this. That's what my cosine curve should look like now. So we need your amplitude. Brandon, what is my amplitude?
Freaking 3.
Good. So it's going to go up to positive 3 and go down to negative 3. Then you have 3a. Yes.
So like,
What's 1/2 plus 1/2?
1. Wait, what am I gonna?
1. There's a 0. Can I put the opposite?
Oh.
It's 1, right? Or pi.
Yeah. Okay.
So 1/2, a half a pi plus another half a pi is a whole pi. Okay, and then I have a whole pi and I add another half a pi. What do I have? Yep.
Question. So you have pi over 2,
Yep.
and then that means it goes up by pi over 2 more times.
I keep adding because they're equal distance.
So when I look at the thing, am I looking at the cosine?
We are looking at the cosine.
It's like 0.
Well, we're not. Don't plug it in. Okay.
I don't. Yeah, feel like I don't know how to add like pi over 2. Can I just like put it next to each other?
Pi over 2 plus pi over 2.
So wouldn't it be like pi over 4?
1 plus 1 is, no, you don't add the denominators.
Oh.
1 plus 1 is 2 pi over 2, which is a pi, right?
Okay.
Okay, then we add another pi over 2 to get here, which is 3 pi over 2. Any questions over that? Okay, now we're going to graph it, so let's plug it in. To get negative 3 times the cosine, we're going to plug in 0 first. What's the cosine of 0? 1. So then we get negative 3 times 1, which is negative 3. So it starts down here. Okay, then we go to pi over 2. So we get negative 3 times the cosine of pi over 2. Cosine of pi over 2 is 0. So negative 3 times 0 is 0. 2 pi. Negative 3 times the cosine of pi. What's the cosine of pi? Negative 1. So negative 3 times negative 1 gives me positive 3. Where should it go from there? Back down to 0, then what? Go down to negative 3. Any questions on how this should go? Okay, so those are my cosine curves. Any questions? All good? Okay, everyone, try the next one on their own. You can do this. so what goes at the beginning? Can someone tell me? Adding pi over 4. Pi over 4. You're still having issues counting. You guys don't know your fractions. Okay, pi over 4 plus pi over 4 is 2 pi over 4, which reduces to pi over 2. Then add another pi over 4. 2 pi plus 1 pi is 3 pi over 4. Do the math if you don't know how to do it, you guys. It's not that difficult, and the more you do it, the easier it becomes. Yes? Yes, sir?
What is radical 2 over 2?
I don't know.
No. Like, cosine?
I'm going to show you right now, so if you think you do that. Okay. Now, the second part that you guys didn't understand, most of you guys together when it's to pi over 4. When you plug in pi over 4, it's 2 times the cosine of 2 times pi over 4. You have to do this part first. You don't tell me the cosine of pi over 4 is first 2 over 2, because that's not what I'm asking. I'm asking you to find the cosine of 2 times pi over 4. Okay, and that will reduce the cosine of pi over 2. So what's the cosine of pi over 2 now, Ryan?
0.
0. And 0 times 2 is 0. Yeah.
On example E,
Yeah.
that's what I did, and it worked.
And E.
Yeah.
Because there was no number being multiplied by that, right?
Oh.
If there's nothing there, you don't have to multiply. But see here, you had to multiply by pi over 2 first.
So you don't want to reciprocal that? Like on F, you didn't do reciprocal?
No.
When do you want to reciprocal?
When we're doing the reciprocal function. When we do the secant.
Oh, okay. Never mind.
Okay? So then if you go down to negative 2, then you should go back up to 0, then you should go up to positive 2. Just memorize the pattern, guys. Yep. The only thing that's going to change is the reflection. The reflex is going to start down and go back up. Okay? If you can't remember the pattern, because you guys don't memorize very well, then you have to plug it in.
Oh,
Okay?
what the heck? I think I got like...
You need questions over that. Okay, now we're going to write the equation of the cosine function. Okay, our equation is y equals a times the cosine of d theta. So we need to find the a and the b in order to find the equation. So the a is the a is the amplitude. Let's see what's my amplitude here.
Still fancy.
I wrote it in. What's the amplitude? I just wrote it in 2, right? Because it goes to 2 and negative 2. So that's the amplitude. Okay? The easiest way to do that is just to draw in the amplitude. Okay, then we need to go with the period. I don't know the b because it's the frequency. I don't know how many cycles are between 0 and 2 pi, because 2 pi is not even on the graph. So I have to find the period first. And then so from here to here is 1 cycle of my cosine curve. So the period equals 8. Any questions over that? Okay, but that's not the b value. So you need to remember our formula for period. It is 2 pi divided by b. So now we're just going to cross multiply. b times 8 is 8b. And then 0 times 2 pi Now you can just plug all that in. Y equals my amplitude of 2 times the cosine of my b value, which was pi over 4, times theta. Thanks for waiting. Any questions over that? No, good. Okay, almost done. Now we have to figure out the pattern for secant. Okay. So secant is the reciprocal of cosine, just like cosecant was the reciprocal of sine. We're going to do the same steps we did for the cosecant as we did with the secant. We want to find the reciprocal. Let's start with this one. The first point is at 1. Okay, the reciprocal of 1 is what class? This little 1. 1. Okay. What is the reciprocal of negative 1 class? Negative 1. And this little 1 is 1. Okay, the next point that's easy is this one right here, the 0. Okay, the reciprocal of 0 is 1 over 0. And what's 1 over 0 class? Undefined. Those are my asymptotes. So I draw in my asymptotes wherever there's a 0. My cosine. Then what did cosecant look like? Parabola, right? On the amplitude. Okay? Same thing with secant. Okay? Cosecant is just parabola. It catches the amplitude and it stays in between my asymptotes. So this is what it looks like. Okay, you don't have to plug the numbers in. You just need to know what the pattern is and what it looks like. Any questions over that? Okay, so it looks very similar again to cosecant. The big difference is with cosecant, our asymptotes were on the x-axis. Okay, here our parabola is going to be on the x-axis. So the cosine starts at 1. Our sine started at 0, so that's why we have asymptote at 0. That makes sense. That's the big difference. I can tell the difference between the two graphs. Any questions over that? Okay, let's graph the next one. So let's start by, this is 3 times secant of 3 theta. We're going to graph 3 cosine of 3 theta first. Okay. So we want to start at C and then negative 3.
Theta.
In the period is 2 pi divided by the b value, which is 3. So it's 2 pi over 3. Now this is a fun one because you have to be good with your fractions, which we're not always. So remember we take 2 pi over 3 and we divide it by 4 to get the start point. What I'm really doing is doing 2 pi over 3 times the reciprocal of 4 is 1/4. So I get 2 pi over 12, which is pi over 6. Okay, everyone graph cosine and then graph secant.
On the same one?
Yep, because that's what we did here, right? We had the graph of cosine, and then we had the graph of secant using cosine. That's what we're going to do here.
So this one 3.
No, zero.
I did pi over 6.
So we have to do pi over 6 times 3.
Yeah. And I got pi over
Pi over
2
2.
is 1.
No, that's the sine.
Yeah.
We're doing, no, secant. Not sine.
Oh, so it's a 0.
We're dropping cosine.
So 0.
Now we're doing secant.
So this is 0.
No. Hopefully today, I'll have them in today. Okay. So our cosine curve should look like this. So our secant is going to have asymptotes at pi over 6 and pi over 2. My parabola is going to be at 0.
Oh.
And at pi over 3. And then at 2 pi over 3 again. Any questions over that? Anyone unsure on how we're doing this? Okay, let's get to work on your homework. Okay, on the homework it's also asking you for range. Okay, the range is like how high and how low it goes. So it's very similar to the amplitude. So if you look at number 1 on your homework, what is the amplitude on number 1? 1. So my graph is going to go up to 1 and down to negative 1, right? The y value is not going to go higher or lower. So my range is in between negative 1 and 1.
Wow.
Okay?
Can you just put like 1?
No. Because that's not the range. The range is all the y values. What can your y values be? Your y values can be anything in between 1 and negative 1.
Can we just write the y values then? All of them?
No, because you can't put, do you want to put 0.000009? Point.
No,
Right?
no, no. Just like, just write negative 1, 0, and 1.
No,
Isn't that what that's saying?
no.
Oh,
That's saying any value between 1 and negative 1 will be a y value.
I'm not going to do it.
Okay.
Are you going to be mad if I don't do range?
It's going to be on the test, you might as well just learn it. It's very easy. It's not like very difficult to do. Just put y in the middle and your amplitude at the end.
Oh,
Every
yeah.
single time,
Is the sign
right?
going to go the same direction?
The signs are always going to go that direction, yeah.
The line underneath it. Okay.
Any other questions?